Good morning, Year 5s. It is Friday. It is the last day before our half term, which sounds weird to say, but you know, you've been working hard at home. We've all been working hard at home. So it is time for a little half term break very soon. And it's important to keep to those routines as well. So, our final day before we have a little rest for a week. So, let's have a look at our Friday's maths. Now, this video is going to look at the first half of questions. So this video is going to be the do now, and then these sets of questions, which is the main part, okay? I'll then make another video for these last sections, because they're a big step up, okay? So at the bare minimum, I'm saying right at the start, the expectations that I want you to do are these two sections here. If you're very confident with those, take a look at the next video. If you think, oh, I've managed that, but only just, then that's fine. You can leave it there, okay? And I will post the second video later. I'm going to get all the videos up so you can all get started, and then I need to make a separate one for these ones to go into a bit more depth, okay? So if you are going to have a look at these ones, the video might appear a little bit later than all the others. So let's get started. Converting 99 centimetres into a metre. So, where are we? There we are. We should hopefully know that is simply 1 centimetre off a whole metre, off 100, so it's 0.99, because we have not got anything in the hundreds there. 12,988 metres. Well, we know that there are 1,000 metres in a kilometre, so 1, 2, 3. So it's going to be 12.988 kilometres. Sorry, I didn't leave myself much room there. 0.4, 40%. Because remember, that's in the 10th column. That's not a 4, that is a 40 hundredths. A 4 tenths. And then 4% is 0.04. I've put them there so you can see the difference. 4 sevenths equals 12 watts. So, what have we done to the 4? Well, we've times it by 3, haven't we? So, whatever we do to the top, we do to the bottom. 21. Boom. What are the size of a 3D shape called? Faces? Oh, actually, no. Sorry. The sides. If you look at a square, you say that's the side, 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 don't you? So, it's an edge. Okay. The faces are a flat surface, and that's, you know, so it's an edge. My apologies. It's an edge. Can you sketch a cuboid? Now, to sketch a cuboid, you start with a rectangle like that. And then it's all about perspective. You have to go back that way and get that face there. Then you can join that one up. Oh, it's not bad, you know. It's not bad. So there you go. Have a go with that. I have no edges and no vertices. What am I? Well, you are a sphere. Draw a right angle. Boom. What is a formula? It's an instruction to follow, basically, isn't it? So a formula is an instruction that you follow to solve a certain task in maths. So you can give an example. We all know one. L times W equals A. So L times length times width equals A, and you can insert any number in there. You can insert 10 and 1, and the area will be 10. You can replace it with numbers. It's an instruction to follow. So, you could say it's an algorithm. What unit of measure do we use for capacity? Well, depending on the size, you've got millilitres or litres. You've also got centilitres in there as well, that you see on cans quite a lot. Right, on to the task for today. So, on your screen, you should see these guys. Adding and subtracting mixed, proper and improper fractions. Now, we've done same denominator stuff in do nows in class. So really, your only bit of where you might get, ooh, what do I do here, is on this side, okay? Like I said at the start of the video, this is your main task today. Everything that follows is that little bit extra, okay? So at the bare minimum, do these. So, the ones on this side, I'm hoping you do these straight off. We've done this in our do nows. If the denominator is the same, all you focus on is the numerator. You don't take away any pieces. Like you don't cut it up into more pieces. You just take away the numerators. Okay. So if it's 2 ninths and 2 ninths, well, now you've got 4 ninths. So we can have a look at these nice and quick. Where are we? Oh, we're all the way over there. Put my book up there a bit more. There we go. A weird angle today. What are you doing? There. There we go. Still not right. Cool. There we go. So, first one, 2 ninths and 2 ninths. Well, that's simply going to be 4 ninths, isn't it? Okay. It's just, you've got 2 chocolate bars. You've cut one into you've got them both into ninths. You give 2 pieces. You get 2 pieces from each. You've got 4 pieces. 1 12th and 2 12ths. Well, that makes 3 12ths. It does not make 3 24ths. Okay, because 3 24ths, the 24ths are a lot smaller. When 3 24ths is not going to be the same as 3 12ths because the pieces are smaller. 2 thirds. 2 thirds. I'm looking at 2 ninths and 3 ninths. Well, that's simply going to be 5 ninths. This should all be flooding back from our do nails in class. And the same with these guys. Nothing different, it's just subtraction. So 2 quarters take away 1 quarter. Well, that's 1 quarter. 10 take away. I'm just looking at the top. 10 take away 8 is 2. And then 2 take away 1 is 1. Boom. Lovely. It's these ones that I wanted you to have a closer look at today. So, when you come to these, you can't just add 3 and 2 and put 5 because the denominators aren't the same. Okay, and remember, in fractions, you need to have the same denominator. It's like conversion, it's like using measures. You can't say, oh, my garden is 10 metres by 15 centimetres. What? That would be a tiny garden, first of all, but also, it's very tricky to do. So, you need to get these to have the same denominator. So, we're looking for the lowest common multiple, so that go through the times tables of both until you see one the same. Now, because 10 is above 5, let's work with the 5. 5, 10. Ah, lovely. So, that means we've times this one by 2. So, whatever you do to the top, bottom you do to the top, we'll times that one by 2 as well. We don't need to touch this one because we want 10. So this fraction here becomes 10 4 tenths. Can you see now how that is a lot easier to do? Now we've got 3 tenths, add 4 tenths. Well, that's easy, isn't it? Because the answer is just going to be 7 tenths. Okay? So you don't have to do it. You don't always have to do anything to both fractions. Same with this one. Oh, we've got 5 sevenths and 1 14th. Well, I know straight away, my brain is telling me that 7 times 2 is 14. Let's not touch that. Let's use the 7. You could divide by 2, but you can't because that's only a 1. You're not going to get anywhere. That's the smallest piece you can have. So, times that by 2, which means we need to times that by 2, which, I've got no room, which becomes, I'll do it, which becomes 14 tenths, okay? So 10 14th, add another 14th, well that's 11 14ths. Same with this one here. I can see this here, I've got 9. Well, that's times 2 to make 18. So times them both by 2. I'll leave this one alone. So that becomes 9 times 2 is 18. 4 times 2 is 8. So 8 add 3. 11 18ths. And it's the same with these guys over here. Same again, we've got a 7 and a 14. Times that by 2, times that by 2. We've got ourselves 2 14ths. Now they're both the same denominator, because that's that fraction there. 9 take away 2. 9 take away 2 is 7. 7 twelfths is our answer. 14ths, sorry. 7 14ths. You could look at that and go, actually, the answer's half then, isn't it? You could convert that to half. You could simplify it. 9 20ths take away a quarter. Now, again, my brain's thinking, ding, 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 instantly, I can get to 20 by timing that by 5. My pattern sniffing is kicking in. So, times them both by 5, I get, I've run out of room again, 25 20ths. because I've times the 1 by 5, which is 5, and the 4 by 5, which is 20. Then I've got 9/20ths and 5/20ths, taking them away. So 9 take away 5. Wow, that's going to be 4, isn't it? Isn't it? Yeah. A bit of a brain blank then. You could simplify that as well. You could half that. You could give an answer of 2/10. You could halve it again and have 1/5. Well, but that's for another time. That's when we're going to look at fractions again. And the last one. Oh, that one's nice, isn't it? Which times in both of those by 2 to get 6/8. So then we're working with eighths. 7 take away 6. Oh, lovely. The answer is 1/8. There you go. So, all of those, pattern sniffing, using our times tables. If you're happy with that, take a look at the next video, but a heads up, it is a big step up, and I will do them in an order that is easier, but the next questions on the sheet, you do not worry if you do not understand some of them or all of them, okay? The main bit was this bit today, okay? So if you have a look at the video and go, no, I don't get that, genuinely, then fine, enjoy your half term, thank you for doing the maths this half term. If you look at it and go, alright, I'll give a couple of a go, then fine, I'll see you in the next video. But brilliant work, guys, fantastic. And thank you to everyone who's been doing their maths over this whole half term that we've had.